Hello and welcome to this look at a calorimetry Q equals mc delta T leveled response question. It's question 2A from the 2017 OCR Unified Chemistry paper. So let's begin by having a look at the question and what it wants us to do. So quite a lot of information there, so let's take it one step at a time. The student wants to determine the enthalpy change of this reaction. So it can be done using Hess's law. So that means a Hess law cycle will be used at some point. So we've got two reactions here, reaction 3.2 and reaction 3.3. 3.3 gives us the enthalpy change already, and we have to calculate the enthalpy change of reaction 3.2. So looking at all of this here, this is basically the procedure that the student has carried out. This is their readings, and it says at the bottom the density and specific heat capacity C from the data sheet of the solution are the same as for water. So going back to reaction 3.1, you can see it's connected to reaction 3.2 via Na2O, and that makes 2NaOH. Now that's connected to reaction 3.3, isn't it? Because you can see NaOH in reaction 3.3 because there's a connection point here. So it's quite possible that there will be maybe two of these reactions happening in order to have 2 NaOH to match the 2 NaOH there. So these are just a few thoughts that are coming into my head as I look through it. And then it wants us to calculate the enthalpy change of reaction 3.2 and the enthalpy change of reaction 3.1. So two different reactions to calculate the enthalpy change for, and they want us to show all our working. So let's now go back to the question and all the information it gives us. So first thing to do is to look at the mass readings. Clearly you can work out the mass of sodium oxide and also the mass of the water being heated. So it's a sort of Q equals mc delta T taking place inside aqueous solution. So it's the water that's being heated up as the surroundings. So it also has the fact that the density and specific heat capacity C of the solution are the same for water. It's also got some temperature readings, so we can work out the change in temperature, which is going to be delta T, which is 35.0 degrees Celsius. Now from the data sheet it says that C for water is 4.18 joules per Kelvin per gram. So that means we can actually make use of that. And then it says about 25 centimeters cubed of water. Now this is an easy trap to fall into, because about 25 centimeters cubed actually ended up being not 25 exactly, 25.75 grams of water. So always check your data before going ahead and doing any calculations. So the next thing to do is to construct our answer. So it asks us to show all our working, so I'm just going to move all of that stuff I've just worked out onto here. And then we're going to put the section of the question where it has all the information that we need. So I'm going to start off with reaction 3.2, which is this one here. So collecting my information from my calculations before, I can work out that Q is 3,767.225 joules, remembering that the number that comes out of this is in joules. Now I need to work out how much sodium oxide I used, so I just do mass over mR, and that gives me 0.02 moles. So my enthalpy change is going to be minus Q. So why minus Q? Well, it's because it was a temperature change, an increase in temperature rather. So therefore, what that means is that there's energy lost, hence why the minus goes in front. So that gives us minus 188.3625 kilojoules per mole. Notice that what I did is I changed the 3767.225 joules into kilojoules by dividing it by 1,000. So reaction 3.1, it says this enthalpy change can be determined indirectly using Hess's law. So I'm going to use a Hess's law cycle to do this. So putting the reaction across the top, I'm just going to quickly explain where those two things in that little box came from. So reaction 2 is making 2 moles of NaOH from here. Now, it says H2O liquid, and that's not listed along the top here. But there's quite a lot of things in aqueous solution. So one of the reactants is in aqueous solution, so you can assume there's a plentiful supply of that water that goes in there. So 2 lots of reaction 3.3. So reaction 3.3 uses up 1 mole of NaOH, but I've got 2 moles of NaOH here because that's come from this one, hasn't it? Reaction 3.2. So I've got to double reaction 3.3. It makes 1 mole of NaCl, but I want to make 2 moles of NaCl. So that's a sort of quite a subtle thing to spot there. So once you've nailed that one, you can then label up the different enthalpy changes. So A is going to be the answer, B is going to be our minus 188.3265, and C is going to be 2 lots of minus 57.6. So all you have to do is add them up, basically, and that gives you minus 303.56125 kilojoules per mole to the minus 1. Okay, as always, thanks for listening. Until next time, see you soon.